As a continuation of the really an older project prior to the Gen 3 Prius Inverter-Converter, hacking out basically to be able to utilize as an inverter for pretty much whatever input generator that's been rectified to DC, including multi-phase, three-phase systems or multiple, sources, say a single engine and multiple mechanically synchronized, well, it doesn't even need to be synchronized, rectified, so multiple generator sets, or I suppose you could also have multiple generators with separate engines, just rectifying the output and then inputting, and not just as a three-phase system, but if you wanted to just, in parallel connect, or, within the limitations of that inverter converter, which is, looks like 600 volts. And current-wise, I don't know exactly, but assuming can handle somewhere between 20 kilowatts to 60 kilowatts. Prior to that, I was looking at making a function signal generator, initially when I started studying electronics, and I wound up investing in one of these little generic, it doesn't look the same, mine's a red board, but anyways, and I don't have it handy, I have it stashed away somewhere, obviously, because I don't use that often. Actually, I've only used once to test, but at the time I thought it was kind of neat because there's the options of the different waveforms. Well, I figured I'd look real quick again just to see what's out on the market, and basically, this is old, but this was, I think, new maybe in 2018, or newish, wasn't as common. The cheaper ones were maybe more appealing, but I noticed this one has an arbitrary waveform, so a user-defined waveform option. I wondered what that was, so I tried looking around a little bit. I see Hackaday has a not-so-great review, but details what I had already, before I found the Hackaday article, was wondering about these 9850s, or, because I think I have a module somewhere for one of those. I think that was for mixing is what I wound up getting that for when I was looking at making a spectrum analyzer, homebrew spectrum analyzer. Now, I'm not familiar with the 9833, but I happen to already have this website open on how to build your own function generator using a 89833, and I thought this is really interesting, and this is what got me kind of looking back at these chips again, because now this goes into detail of the build, but something I need to read into a little more was the offset. Looks like there's already an offset option, and you can see here they note clock signal, the peak-to-peak, the frequency, and with offset. Now the others, they don't show the offset. Now they don't have the offset set, so whatever that argument is, that variable. But the waveform is literally offset, so it's down a little bit more in the negative than the positive. So this in particular wouldn't have anything to do with the generators. This would be kind of later what I was thinking about for making the custom, using that DDS red colored older style function generator, or maybe for an interface it's easier, instead of having that larger device, I think it's a Atmel chip, one of these little pulse width frequency generators. I think they call it a meter, but it actually generates an output. And then there's this other one I want to pick it up. Oh, wait, that's not the pulse width one. That's a pure sine generator. This little module here. So it's even smaller. So I thought that'd make an easier welder interface. Now, like again, we were talking about the welder, and in particular, changing the waveforms from a DC output system to whatever really you wanted to. And this kind of got me into, I don't know how to offset this, but this is a EGS002 pure sine wave driver. So you can take and this is where it helped studying inverter designs, was how the little, 12 volt, 24 volt, or 48 volt modified or square wave type inverters can be modified just using this chip, and a little bit more probably going on, but this module to make a pure sine wave output board. So I was thinking, okay, this paradigm of thinking used to switch the transistors or whatever, control the IGBTs, or maybe MOSFETs, but IGBTs, to control more of this. What I was really thinking, ultimately, the whole real main goal was an offsetter they call a balance control for welding AC, welding aluminum, and what they call an AC, but it's really a DC electrode positive and a DC electrode negative offset. So seeing that this chip alone has that capabilities, it looks like, pretty easily, I'm guessing, I'm going to kind of look into this a little more. But I want to note that just to kind of get the idea of my paradigm of thinking for homebrew, just more commercial, off the shelf controlling of the IGBTs, or maybe they're maybe a higher current MOSFET H-bridge design for this is kind of that newer design, the DDS function signal generator. Function, I guess, would be having the more than just a sine or a square wave, which would be a signal generator. Typically, I think is what I think even the article noted here. And then I'll note here too, I found this was referenced in the comments, 809850 waveform generator. I don't think I've seen this one in particular before, but I've seen before. So kind of wondering here what, can be generated and also with an offset. So you have a really, ideally, like I'm thinking here, a smaller package that would be easier to integrate into an existing welder, or a module where you're taking, say, like a tombstone rectified welder output, and you basically plugging those leads into, say, an intermediate inverter box for the welding, ground, and the stainer or TIG torch, or I guess if MIG welding too. But basically having that intermediary inverter, and then simplifying and packaging down so it's easier to electromagnetically shield from interference this controller. Or I don't know, I have to read a little bit into these 9850s, but this really looked promising, having that offset already built in. So it seems like it'd just be a lot easier to develop, and if this is already developed, integrate into the switching of the IGBTs in that inverter, which, so not only you want your pure sine wave and whatever that is, your frequency and your voltage and your current settings, for a generator design, having that also functionality for welder and for plasma cutter, so more versatility. A lot more complicated than I'm really my subject matter expertise is, but got to give you that paradigm of thinking to get more of an integrated, and really for me to look back at later to see my development of thoughts, and then really needing to study a little more the circuit intricate details of that signal conditioning. So you're doing like DC logic alone converting. So if you have something where if it's not an analog 0 to whatever the voltage is for the actual waveforms output, if you have to convert that into some digital 3.3 volt or 5 volt or 12 volt logic to control the IGBTs, which I don't think that's a situation from what I understanding. I think that's an analog. IGBTs are an analog device, but I'll have to read into a little more controlling within the specification. So you got that kind of, what do you call it, level shifting? It's not really level shifting because it's not digital, but it'd be that range of, like, it's a linear 0 to 3 volts, to gate control the IGBTs, or is it, your output here is 0 to 3 volts, and your actual gate control 0 to 12 volts. You're going to have some kind of proportional controller, to accurately, if it's linear, whatever the different graph is, to control that range of operation for that H-bridge switching. Okay, that's about all that came to mind I wanted to document. Take care, be safe, stay healthy, until next time. Bye for now, and keep Christ with you.